All right, so in this video, I'm going to talk a little bit about implementing time value money calculations. So first, let's talk a little bit about timelines. So if you have a situation in which the amounts or periods or sign of the cash flows are changing, I strongly recommend that you actually write out a timeline. Or you can do it in Excel or on paper or whatever, but basically just sketch out the length of time with the different periods subdivided in there, and then start keeping track of what cash flow is happening when and what the sign is. And when you're doing that, make sure that you are consistent such that my recommendation is to make it so that any cash inflow, so any cash that's being received is given a positive sign, any cash that is an outflow is given a negative sign. Make sure you're consistent all the way throughout. Now, as an interesting thought, sometimes you can actually potentially simplify a problem by adding a phantom payment, or maybe even uh, basically therefore sort of converting a series of cash flows into something like an annuity, and then essentially performing the calculations off of that, and then removing the effect of it. That's a little bit more of an advanced kind of approach, but occasionally that's something to kind of think about. It might be able something you could simplify things. So you could essentially add in a cash flow that's not really there if it simplifies everything, and then make sure you just undo the calculation. So if you were finding the present value of a series of cash flows, for instance, and if adding in one payment and you say year five would turn the whole thing into an annuity, then you could put in sort of a phantom payment, calculate the value as an annuity, and then just subtract out the present value of one payment in or one value in year five at the end of your present value calculation. So it's not something you'll necessarily do a lot, but sometimes you could simplify things potentially if you're strategic about things like that. And ultimately, the more you understand sort of what's going on and the principles behind it, you'll realize there's more than one way to solve problems. And historically, I've been kind of surprised by occasionally people solving problems in an interesting way, and I kind of have to look at it and think, huh, that's an interesting way to do that. And I think about it, and like, does that work? And I realize, well, you know what? Actually, maybe that does work. That actually is, it's not violating any time value money concepts or principles there. They're just approaching it a different way. So sometimes there's more than one way to solve a time value money problem. But if you've got unusual cash flows that are fluctuating or changing, some are positive or some are negative, timelines are just a really good tool to use for those scenarios. All right, now a few little notes as far as using a calculator. So if you're using a TI-83 Plus calculator equivalent, it does have the ability to do time value of money calculations. And so you can go to apps and then finance and then TVM solver to do that. And if you're using a TI-83 Plus or equivalent, you could set the P/Y and C/Y to 1, and then just leave them alone after that. And there's a begin and end option that you'll see, and that basically controls the type of annuity. So begin would set it for an annuity due, end would be for an ordinary annuity. And my recommendation would be to set it on end to kind of set it on end unless you know for sure you need it on begin. And then if you're done using your calculator for an annuity due problem where you need to begin, set it back to end, because ordinary is more common. So my recommendation is by default to kind of leave it on end. So if you forget to look at it later, it's set correctly. Um, if you're using a TI BA2 Plus, which has time value money calculations embedded in it, the rules are very similar. And basically, you can select or input data for N and I and PV and payment, and then you can solve for future value, for instance. So the keystrokes are a little bit different, but the functionality is basically the same. If you're doing it in Excel, there are a whole series of interesting functions in Excel that are to be used for time value money calculations. So I have a few listed here. So equals PV, equals FV, equals payment, equals rate, equals NPV, equals IR, equals MIR. So let's just kind of briefly skim through those. Equals PV is a function in Excel that enables you to find the present value of either a single cash flow or an annuity, or maybe even annuity and a single cash flow on top of it. So if you had, for instance, a bond and it makes payments every, say, 6 months, and it makes a final terminal payment at the end, in addition to the interest payment every 6 months, you could find the present value of that with the present value function. Future value finds future value of either a single lump amount that's the present value, or of a series of payments, so in equal payments of an annuity. So basically, you can do that for future value. And within both the present value and the future value functions, there's an option to set whether it's an ordinary annuity or an annuity due. And that's actually true for the payment function as well. By default, Excel assumes that you're doing an ordinary annuity unless you tell it otherwise. Or you could explicitly tell it you're doing an ordinary. But if you don't tell it anything, it's an optional argument, and it assumes ordinary if you don't do anything to it. Now, payment equals payment, or PMT, would be if you want to find the payment. So you could use that function to find the payment on a mortgage. So if you go back to the prior video with the amortization example, equals PMT was how you could find the payment for that mortgage. Equals rate would be how you'd find the interest rate that applies to a situation. So if you had a present value and a future value and a series of payments, you could use the rate function to find the rate that applied there. And it's important to note as it relates to that function, well, and really to all of these functions, you have to be very careful and very consistent about the signs used for the numbers. So my standard recommendation is any cash flow that's coming in, give it a positive sign. Any cash flow that's going out, give it a negative sign. And then if you have followed that rule and you've not made any errors on that, and if you are using the correct numbers, then the function or your calculator, whatever you're using, so a function in Excel or calculator, should give you the correct numerical answer. The sign on the answer may or may not have meaning. So if you, for instance, just did equals PMT, you put in a positive present value for a loan, kind of like I recommended in the prior video. You filled in the rate, you filled in the number of periods, and hit enter to solve for the payment. Excel will spit out a negative number. So just make sure that if you're actually using it in Excel, that the context of how you're using it, that you would want that negative. If you don't want the negative, then you're going to need to put a negative sign in front of that whole function to switch the sign around. So when using a calculator or Excel, I've got basically two rules that are the same. Any cash flow coming in should get one sign, and any cash flow going out should get the opposite sign. And I recommend any cash flow coming in should be positive, any cash flow going out should be negative. And then two, provided you followed rule number one, interpret the sign on the answer that your calculator or Excel spits out, kind of with the proverbial grain of salt. So kind of don't get too attached to the sign on the answer that's spit out. Make sure that you use it the way that that the number should be used, but the number itself should be correct, but maybe not the sign on it. So kind of pay attention to that. I'm also kind of noting a couple of functions here that are handy, and I plan to talk about them in future videos. And that is NPV, IRR, and MIRR. So for NPV, this actually can be used to find net present value. And basically, it's really handy for finding the present value of a series of cash flows that's uneven. So if you have a series of uneven cash flows, so the amount is different from year to year, I can't just use the present value function, because the present value function, or at least I can't do it to incorporate all the cash flows. Because the present value function requires that every cash flow that's happening from period to period be the same in order to use that. So if I had a whole series of different cash flows, I could use the NPV function to find the present value of a whole series of different cash flows, and that would work well. There is a way I could use the PV function with uneven cash flows, and that's if I just found the present value of each separate cash flow separately. So if I did a separate calculation for every single cash flow, and that would work. So I can do a separate cash flow for each one, add up all the present values, and there we go. But if I wanted to find the present value of a whole series of different cash flows in one calculation, then the equals NPV function is pretty much the way to go. And with that in mind, it's worth noting that you do have to pay attention to what cash flows you're putting in there. So for the NPV function, any cash flow at time 0 does not go inside the NPV function. So that would have to go outside the NPV function. On the other hand, if you are using IRR, IRR can be used to calculate the rate across a series of uneven cash flows. So let's say you invested a certain amount of money in time 0, and then you received money in years 1 through 4, but it's different amounts in each year in 1 through 4. You could use the IRR function to find the annualized rate of return on this investment. And when you are doing that calculation in Excel, equals IRR, you actually highlight all the cash flows starting at time 0 and on. So that's a little bit different from the NPV function. And you follow the same kind of principle for MIRR as well. The MIRR also has a couple of options about a finance rate and a reinvestment rate, but I'll talk about that more in a subsequent video. So big things to remember as it relates to actually doing time value money calculations. Any cash flow coming in needs to get one sign, and any cash flow going out needs to get the opposite sign. And then 2, provided you're using the right numbers and you're following rule number 1, interpret the sign on the answer that you get with kind of a grain of salt. The sign on the answer may or may not have a whole lot of meaning. All right, hopefully this video has been helpful. Thank you so much for watching, and have a great day.